Measuring Rate of Reaction Products by KayScience.com. We can measure the rate of reaction of when magnesium reacts with sulfuric acid to form magnesium sulfate and hydrogen by measuring the rate at which hydrogen gas forms. The balance symbol equation is Mg plus H2SO4 reacts to form MgSO4 and H2. To measure the rate of this chemical reaction, we're going to focus on the product hydrogen. Hydrogen is a gas at room temperature, and we're going to measure how quickly hydrogen has formed. In order to do this, we need to accurately measure the volume of gas produced at regular intervals using a timer. One possible method is where there's a conical flask which contains the reactants. There's a bung in the neck of the conical flask with a delivery tube connected to the conical flask. This delivery tube goes from the conical flask to an inverted measuring cylinder. This is a measuring cylinder which is upside down in a trough of water. The job of the conical flask is to contain the reactants. The magnesium ribbon reacts with the sulfuric acids where bubbles are given off. We see this as fizzing. Now, if you ever see bubbles or fizzing in a chemical reaction, this means a gas is being released. In this case, we know it's hydrogen gas because the equation says so. The job of the bung is to prevent hydrogen gas escaping out of the conical flask. The hydrogen gas flows through the delivery tube towards the inverted measuring cylinder, which is in a trough of water, where there is water inside the measuring cylinder. The inverted measuring cylinder is filled to the top with water. The hydrogen gas is bubbled into the inverted measuring cylinder, where it displaces the water, where the hydrogen gas collects here at the top. A timer is used at regular intervals to measure the volume of hydrogen gas produced. I said at the beginning, this is one possible method to measure the volume of gas produced in this reaction. Now, it's not the best method as there are sources of error that we need to consider. Sometimes the bubbles can escape and not be collected in the inverted measuring cylinder. Therefore, one source of error is the gas can escape, and this does not give an accurate reading for the volume of hydrogen gas collected. Another source of error is how the surface of the water inside the inverted measuring cylinder is curved. We call this a meniscus, and because the surface of the water is curved, the meniscus makes it difficult to read accurately. It's question time. Attempt these questions to check your understanding. A gas syringe is more effective than using an inverted measuring cylinder, as it allows us to give a more accurate reading for the volume of hydrogen gas produced. We can see the experiment is very similar compared to before, except the only difference really is there is a gas syringe instead of a trough and inverted measuring cylinder. The conical flask contains the magnesium ribbon which reacts with the sulfuric acid. The fizzing is due to hydrogen gas which rises up into the delivery tube and is collected in the gas syringe. The hydrogen gas is collected here and none can escape. The gas syringe is also easier to read as there is no meniscus and the gradations on the side are much clearer. And with all experiments, when trying to understand the rate of reaction, a timer is used at regular intervals so we can compare how much hydrogen gas was produced at different times. The results of this experiment can be plotted on a graph. On the x-axis is time in seconds, and on the y-axis is the volume of gas produced in centimeters cubed. The volume of gas produced increases dramatically at the beginning. The rate of increase then begins to slow down until no more gas is being produced. This tangent shows how the steepest slope has the fastest rate of reaction. The fastest rate of reaction is always at the beginning of the chemical reaction. This tangent in the middle of the reaction shows how the tangent is not as steep, which shows the reaction has slowed down. Where the slope is flat or horizontal, this means the reaction has stopped as no more gas is being produced. It's question time. Attempt these questions to check your understanding. Pause the video here to practice the keywords. The answers will follow. Press pause to answer the questions. The answers will follow. If stuck, just rewatch the video. Press pause to go through your answers and make any corrections to your mistakes. And don't forget to visit KayScience.com for more videos, worksheets, and quizzes at KayScience.com. And don't forget to like and subscribe.